All right, we're in section 8.1, Introduction to Statistical Test. And in the previous chapter, we were looking at confidence intervals to estimate parameters. Now we're performing what are called hypothesis tests to help us make informed decisions about population parameters. So here's the steps that go into performing the test. Step number one, you establish what's called a null and alternate hypothesis. The null hypothesis is H sub 0, or known as H sub 0. This is a hypothesis of no change in the distribution or no effect. And you'll notice down here in the example, the null hypothesis is going to be of equality. So if you're doing a test on the sample mean mu would equal some value k. The alternate hypothesis, H sub 1, is a hypothesis the hypothesis you adopt when the evidence based on the sample data is strong enough to warrant rejection of the null hypothesis. So for example, if you're doing a right tail test, you would have mu greater than k, where the parameter is more than the stated null hypothesis. Mu could be less than k, in which case it's a left tail test. The parameter is less than stated in the null hypothesis. Or mu could be not equal to k, in which case it's a two-tail test on the left and the right tail. The parameter is different than stated in the null hypothesis. So you need to make sure you know which tail of a test you're using. You're going to see when we do this on a TI-85 calculator, you'll enter mu, and then you'll enter, is it a right tail test, left tail test, or two-tail test. See guided exercise number 1 on page 385. I'll let you look over that. Look at page 386, the types of statistical test, and table 8-1. See example 2, statistical testing preview, and figure 8-1 on page 387. Now, step number 2 is determine a level of significance alpha. This is going to be done for you. The level of significance will be given to you. So what we're interested in is alpha specifically. So this is the probability of making a type 1 error when the test, in other words, you reject the null hypothesis when it is in fact true. So the probability of correctly accepting a true null hypothesis, since they have to add up to 1 or 100%, is going to be 1 minus alpha. We're going to skip over the power of the test for this course. If you were doing this by hand, I would say for step 3, sketch and label the curve. It helps, or at least it helps me to visualize what's going on. You then calculate the observed test statistic, which we're actually going to have the entire test done for us. In other words, what's the z-value? And then calculate the p-value, which is the area in the tail beyond the observed test statistic. And then you'll see that you write an interpretation of the results. In other words, explain what you found. Now, if you don't have sufficient evidence to say that mu is greater than or less than or not equal to k, I'm down here, sorry. If you don't have enough sufficient evidence to say that mu is greater than k or less than k or not equal to k, then we don't say you accept the null hypothesis. We say you fail to reject the null hypothesis, just so you know. Now we're going to do this all on a graphing calculator. The graphing calculator is going to find the p-value for us. So look over pages 387 and 387 to 390 for that. And then once you find the p-value, you're going to compare it to the observed alpha, or to the given alpha value that they will give you in the textbook. So if the p-value is less than or equal to the alpha value, you will reject the null hypothesis in favor of the alternate hypothesis. Look over types of errors, pages 390 to 392, and look over basic components of a statistical test and guided exercise 3 on page 393. And then take a look at table 8-4 on page 395. Here's the recommended homework problems for you out of this section. All right. So let me minimize this and get this a little bit bigger here. And let's see, I think what I'm looking for, let's take a look. Oops. 3, I hope this is the right page. 397. Nope. No. Okay, hold on a second. Having a little trouble here. Page 396. That's what I want. 396. Enter. All right, here's what I want. Section 8.1 problems. So let me, I think we'll get rid of that. I'm going to scroll down and pick an even numbered statistical test. There we go. Yeah, let's go down to something more interesting here. All right. So I'm on page 396 looking at a problem about ecology, hummingbirds. Bill, author, is a zoologist who studies Anna's hummingbird. And here's a reference for the data. Suppose that in a remote part of the Grand Canyon, a random sample of 6 of these birds was caught, weighed, and released. The weights in grams were, here's the following right here. So they give you the answer here as far, you need to know X bar. And so add them together, divide by 6, and you're going to get the mean of the sample is 3.75, right? So they give this stuff to you for most of these. We assume that X has a normal distribution. Notice the population standard deviation is known here. Sigma is 0.70 grams. It's known that for the population of all Anna's hummingbirds, the mean weight is 4.55 grams. Do the data indicate that the mean weight of these birds in this part of the Grand Canyon is less than, which means it's a left tail test, 4.55 grams? Notice they give us the alpha level. Alpha equals 0.01, right? So I'm going to get over to my graphing calculator here. We're going to do stat I'm going to arrow left to go to test. We want option number 1. We're doing a z-test. So I'm going to press enter. Yeah, all right. So mu under the null hypothesis, so it's known that for the population weight, the mean weight is 4.55 grams. So mu sub 0 that you're going to enter on the calculator, that's the mean under the null hypothesis, is going to be, I just lost it, 4.55. We're going to press enter. Sigma for this data is 0.70. I'm just going to enter 0.7. X bar for the data was 3.75 grams, 3.75. Sample size was 6, which I had from a previous example that I was looking through. So I'm just going to retype it there. N is 6, right? And remember that we're looking to see, do the data indicate that it's less than less than 4.55 grams. Oh, I can't do the 4.55. Anyway, so we're doing a left tail test. You're going to arrow down to where it says mu, and then arrow to make sure it says less than mu0, which is a left tail test. You'll press enter, go down and calculate, press enter. All right, look at this p-value here. So all we're doing is comparing p to this alpha value of 0.01. Notice that let's say this is 0.003, okay, to the thousandth place. So your p-value is less than the alpha value. So that is sufficient evidence to reject the null hypothesis in favor of the alternate hypothesis. So it does appear that the mean weights are less, based on this particular sample, the mean weights are less than 4.55 grams. And remember, for any of these videos or material in the book, please feel free to email me or get in touch. Thanks.